These are the notes for how to do the walker's velocity and acceleration graph. And if you notice, I have a practice set of instructions at the top and the homework ones at the bottom. So we're just going to do the practice ones right now. And there are two graphs. There's one on the top of the page, which is distance over time. That's the one we're going to do first because that's a velocity graph. So it says a woman runs forward 10 yards in 2 seconds. Well, let's look at this graph here. In your math class, I know a lot of you have been learning that slope equals change in y over change in x, okay? Well, we just learned the other day that the change in distance over the change in time is velocity. So you could actually say that the velocity is the same thing as the slope of this particular graph because I have distance on the y and you have time on the x. So what we're going to do right now is we're just going to draw out what this woman did. So if she runs forward 10 yards in 2 seconds, what you're going to ask yourself are those two questions. How fast did she go? And also, how much time did it take her? Well, she went 10 yards. I'm going to go up to the 10, and it took her 2 seconds to get there. So I'm going to go up to the 10 over to the 2. In part B, she says she stops for a second. Well, she stopped. She didn't go any distance, and she did that for 1 second. So the two questions you ask yourself is how far did she go? Well, she went 0, and she went there for 1 second. So I'm moving that over. Okay. The third one down, letter C, says she turns around and walks 10 yards in 5 seconds the other direction. Well, she walked, when I asked myself how far did she go, the distance, that means she went 10 yards, but it's the opposite direction. So she's going backwards. This is a velocity graph. And so if she goes backwards, I'm going to go down from the 10-yard line to the 0. And 5 seconds out of the 3 is 8. So I come down from the 0, 8. Next one says immediately she turns around forward again and walks 5 yards in 5 seconds. So I'm going to go up to the 5-yard line and go over 5 seconds. So now I'm at the 5:13. Part E says afterwards she runs as fast as she can 10 yards in 2 seconds. So how far did she go? She went 10 yards. And it took her 2 seconds to get there. Oh, sorry about that. And it took her 2 seconds to get there. So I'm going to come up here to the 15 now because she went 10 yards, 2 seconds. And then finally she turns around the other direction, goes 10 yards in 2 seconds the opposite way. So now she's going backwards in 2 seconds. And so she ends up with a total displacement, not distance, but displacement of 5. Now her total distance would be adding all these up together. So you take the 10 plus another 10 would be 20, plus another 5 would be 25, another 10 would be 35 and 45. So her total distance would be 45, but her displacement is only 5 yards from the starting point. Okay, so that's the difference between a vector quantity, which is how far you are from the starting point, and a scalar quantity, which is basically how far you went total. The next set of instructions tells you to figure out the acceleration graph. Well, let's look at that now. The acceleration graph, oops, sorry about that. The acceleration graph is on the bottom of the screen. So we're now have to look at what we have here. If slope equals change in y over change in x, now on my y-axis I have velocity, and on my x-axis I have time. Well, velocity over time is acceleration. So once again, now the slope of a velocity over time graph is the same thing as acceleration. So now I have to ask myself two different questions. First of all, how fast are you going, and how much time did it take you to get there? So let's ask ourselves those two questions each time. And let me go up here and get a line on here. And on the first one, if a woman runs 10 yards in 2 seconds, well, 10 yards divided by 2 seconds gives you 5 yards per second. So I'm going to go up here to the 5 yard per second line. And it's when a person does this, they almost immediately go up there. So if you notice, I'm just going to come right up here to the 5 yard, and she went that way for 2 seconds. So I'm going to go over here to the 2. In part B, she says she stops for 1 second. Well, how fast was she going if she stopped? She was going 0. And they almost stop immediately. So I'm going to drop almost straight down. And then how long did she stop? Well, for 1 second. So I'm going to go over to the 1, or to the 3 mark for 1 second. Then she turns around and walks 10 yards in 5 seconds the other direction. Well, 10 yards divided by 5 seconds means she's going 2 yards per second. But since she's going backwards, you have to go below the line. So now I'm going to go to the -2 because she's going 2 yards per second. And she stays going 2 yards per second for 5 seconds. So I'm going to go over to the 8. Now, in part D, she turns around immediately forward again and goes 5 yards in 5 seconds. Well, ask yourself, how fast was she going? 5 yards divided by 5 seconds gives you 1. But since she's going forward, you have to come up here to the +1. And she's going to go to the +1 for 5 seconds. Okay, so now I'm going to go over here to the, I don't know if I'm doing it, 1, 2, 3, 4. I do one more there. And dip that down too much. All right. In part E, she runs as fast as she can, 10 yards in 2 seconds. Well, 10 yards divided by 2 seconds means she's going 5 yards per second. So I come straight up to the 5. And she did that for 2 seconds. And then finally, she turns around immediately and runs 10 yards in 2 seconds backwards or the other direction. Well, if she's going forward and then goes backwards, she had to come down past the 0 and stop and then run 5 yards per second for 2 seconds the other direction. Okay. So that's how you do both the velocity and acceleration graphs.